Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at the correction of the Mafa online pure math test 1, which was launched yesterday, the 16th of November. So for those of you who have not yet taken the exam, please, it is preferable to take the exam first before you come and watch the solutions. That's, you come and follow the correction. So if you want to take the exam, just click on the description of this video and you're going to see the link to the exam. It's a 30 minutes exam and you have a total of 20 questions to answer, 19 multiple choice questions and 1 structural question. So those of you who have taken it already, it was a great try. I believe you saw your score already, and nevertheless, if you failed, no problem. If you passed, no problem. You just need to keep working and keep working. Alright, so let's get started. So we are going to begin with question 1, which reads: the sum of the first n terms of a sequence is given by s of n equal to n into 1 plus 2n times ln 2. The fourth term of the sequence is, so we have the various options. So the very first thing to recall is, how do we get the n term of a sequence? So the n term of a sequence is given by the sum of the first n terms minus the sum of the first n minus 1 terms. So since we need a fourth term, it means we need t of 4. So t of 4 will be equal to the sum of the first 4 terms minus the sum of the first 4 minus 1 terms, which is basically the sum of the first 4 terms minus the sum of the first 3 terms. Now, since we have the sum of the first n terms, it means we can get the sum of the first 4 terms as well as the sum of the first 3 terms. The sum of the first 4 terms is just gotten by replacing n with 4 in the sum of the first n terms. Replacing, you're going to get 36 ln 2, and for the sum of the first 3 terms, replacing 3 here, you're going to get 21 ln 2. When you do the difference between the two, you're going to get 15 ln 2. So option B is correct. Alright, question 2, you have a binomial expansion question. Nevertheless, you're being asked to find the set of values of x for which the expansion 2 minus 5x raised to the power negative 3 is valid. So firstly, I'm going to give you a general scenario where we have a plus bx to the power n. For it to be valid, then the absolute value of bx on a should be always less than 1. So in our case here, we have the 2 minus 5x raised to the power negative 3. It means our a is 2, our b is negative 5. So for it to be valid, negative 5x divided by 2 should be less than negative 1. Doing all the necessary manipulations, we get negative 2 less than 5x less than 2. We can now divide also by 5 and we get negative 2 on 5 less than x less than 2 on 5. So option A is correct. Alright, so let's move on to question 3. It reads: the roots of the roots of 8x squared plus 2 minus p times x plus 3 minus 4p are of different signs. The range of values of p is. So first of all, let's just say the roots are alpha and beta. If the roots are of different signs, then we have two cases. It's either the first root, maybe alpha is negative and beta is positive, or vice versa, meaning alpha is positive and beta is negative. Nevertheless, in both cases, we always have a situation where whenever we multiply the roots, we are always going to get something negative, because if the roots are of opposite signs, then the product of the two will always be less than 0. Because if alpha is less than 0 and beta is greater than 0, if I multiply a negative number and a positive number, the result will be negative. If alpha is positive and beta is negative, when you multiply, you still get a negative number. Negative means less than 0. So in this case, we have that the product of the roots of our equation 8x squared plus 2 minus p times x plus 3 minus 4p equals 0 are the product of the roots is less than 0. But what's the product of the roots? The product of the roots is just the constant term divided by the coefficient of x squared. So setting to be less than 0, we can multiply by the negative sign. Multiplying the numerator by the negative sign, we get 4p minus 3. we can cross multiply with 8 because it is positive. The inequality sign remains less than. But now since we are multiplying with a negative sign, then the inequality sign needs to reverse to greater than. So from there we can add 3 on both sides and we divide both sides by 4 and we get p greater than 3 divided by 4. So for p greater than 3 divided by 4, the roots of our equation which has been given the roots will always have opposite signs. So option Z is correct. Alright, question 4, trigonometry. It reads, given that theta is between 0 and pi ln 2, then the sign of capital X, where capital X is the sine inverse of small x minus the cos inverse of small x, is equivalent to. So I'm going to first of all start by letting my u to be sine inverse of small x. It means that my sine u will give me x by taking sine on both sides. Same application to cos inverse of x to be v, meaning that cos v is equal to x. Now I need to find the sign of capital X, which is just the sign of u minus v, because my u is sine inverse of x and my v is cos inverse of x. By the expansion, we have this to be sine u cos v minus cos u sine v. We have the value of sine u, it is x. We have the value of cos v, it is x. What about cos u? Now since our angle is between 0 and pi ln 2, then clearly my cos u is just the square root of 1 minus sine squared u. So I have the square root of sine u is x, so 1 minus sine squared u becomes 1 minus x squared. We need to take the square root. Sine v as well, since v is also in the intervals 0 to pi ln 2, it means that the sine of v is just the square root, that I'm just taking the positive square root, the square root of 1 minus cos squared v, which is the square root of 1 minus x squared. So fitting that in our equation, we get our sign of capital X to be sine u is x and cos v is x. When you multiply the two, you get x squared minus the square root of 1 minus x squared, which is for cos u, times the square root of 1 minus x squared, which is for sine v. When you multiply 1 minus the square root of 1 minus x squared with itself, you just get 1 minus x squared. So it means our sign of capital X is just x squared minus into 1 minus x squared. Simplifying, we get 2x squared minus 1, and then we can now factor out the 2 and we are going to get 2 into x squared minus half. So option B is correct. So let's move on to the next question, which is on limits. The question reads, the limit as x tends to positive infinity of 2 raised to the power x plus 5 raised to the power x, all that raised to the power 1 over x is equal to. So as x is tending to positive infinity, what I'm going to do is that I'm going to factor out the function which tends faster to positive infinity. Comparing 2 to the x and 5 to the x, regarding x tending to plus infinity, you see that 5 to the x will be tending to plus infinity faster than 2 raised to the power x. Both of them are exponential functions. The 5 raised to the power x tends faster than 2 raised to the power x because 5 is greater than 2. Alright, so with that said, we can factor out 5 raised to the power x from both terms. We get this quantity. We use our laws of indices, so you have 5 raised to the power x raised to the power 1 on x times your interior here raised to the power 1 on x. But 5 raised to the power x raised to the power 1 on x, you just multiply the powers. So you have x times 1 on x, which is 1. So you just get 5 raised to the power 1, which is 5. And then you'll be left over with this quantity inside here raised to the power 1 on x. But now, as x tends to positive infinity, 5 raised to the power x tends faster to positive infinity than 2 raised to the power x. So 2 raised to the power x divided by 5 raised to the power x by the speed test tends to 0. So our interior here tends to 0 plus 1. Our numerator tends to 0 from above. So the interior as x tends to plus infinity, right, 1 over x tends to 0 from above. The interior tends to 1 and the numerator tends to 0 from above. So 1 to the power 0 from above will be tending to 1, then multiply with 5, we get 5. So it means our limit is 5. So option Z is correct. Alright, question 6 on vectors. It reads, which of the following is perpendicular to both 3i minus 2j minus k and I plus 2j minus k? So a certain vector which is perpendicular to this vector and this vector is just the cross product of these two vectors. That is, any vector that is parallel to the cross product of these two vectors. So if I call the vector to be d, then my d should be equal to a scalar multiple of the cross product of the two given vectors. So either you just do the cross product or you do the scalar multiple of the cross product. I'm going to explain why. All right, so with that said, we can do the cross product of the two vectors using the determinant method. We are going to heal this. And how do we do it? Let me just try to illustrate. So first, we need to cover the section of I. When we cover the section of I like this, you are going to be left with this 2 by 2 matrix. Now, this 2 by 2 matrix, we need to look for the determinant. So we have -2 times -1. You have 2. That's, it goes with the I component, right? And then 2 times -1 is -2. So minus -2. So 2 minus -2 is +4. But since we're covering the I, then you're going to have 4i. So you're done with that component. Now you need to move on to the j component. And remember that the j component always has a negative sign attached to it, following the sign rule. Okay, so when you cover the j component, you now have another 2 by 2 matrix, which is so you look for the determinant. You have 3 times -1 is -3, and then you have 1 times -1 is -1. So -3 minus -1 is -3 plus 1, which is -2. But since the j component always have a negative sign attached to it, that's for the first row, then you multiply the negative sign with our -2 to get now +2. So the coefficient of j becomes positive. Now let's conclude by crossing the j component. So crossing the j component, we have a similar situation. So we cross and we cross. So we get 3 times 2, which is 6 minus 1 times -2, which is -2. So 6 minus -2 gives us +8. The k component is always attached to a positive for the first row. So we have +8. So we see that the cross product of those two vectors just gives us 4i plus 2j plus 8k. But now we are looking for a vector that is perpendicular to both vectors, and like I said, a vector that is perpendicular to both of these vectors is simply a certain vector which is parallel to the cross product of the two vectors. That's why you find your scalar here, which is lambda. So if lambda is equal to 1, you see that we just have option A as our answer. If lambda was 2 and maybe option A was not there, and you have, if lambda is 2, right, you have 8i plus 4j plus 16k. If you saw the answer is also correct. So that's why in a general basis we need our lambda to be there. And then now maybe if we don't see the basis of our vector which is perpendicular to both of the vectors, we now start using various values of lambda. But nevertheless, in this case, if lambda is equal to 1, then we just have option A. So we are good to go. Option A is correct. Alright, question 7 is on differentiation, specifically differentiation of ln functions. The question reads, given that y is equal to the ln of 1 plus 1 on x, then dy by dx is equivalent to. So first of all, recall that you can look for the LCM. 1 plus 1 on x is the same as x plus 1 all divided by x. From the laws of logarithm, we can separate this by taking the ln of the numerator minus the ln of the denominator. If you want to combine the two, since we are taking logarithms, we just need to divide. Since we are involved, we just need to divide the argument since it is subtraction. Alright, and how do we now differentiate a logarithmic function, that's a ln function? We just differentiate the interior and we divide it by itself. So differentiating the ln of 1 on x, the ln of x plus 1, we differentiate x plus 1, we just get 1, because when we differentiate x, we get 1. We differentiate 1, we get 0. Remember, we are differentiating with respect to x. So differentiating x plus 1, we just get 1, and we divide it by with itself. So we have 1 on x plus 1. minus, we differentiate x, you get 1, and we divide it by x, minus 1 on x. So looking at things, option A is correct. Alright, so question 8, polynomial, which is specifically the factor and the remainder theorem. It reads, given that x minus 2 all squared is a factor of this, where a and b are constants, the value of a and b is. So first of all, we are going to see what it means for maybe a certain function to be a factor of a certain polynomial. So let's just let our polynomial in this case to be f of x equal to x cubed minus 7x squared plus ax plus b. Now we are going to analyze in two cases. X minus 2 all squared is a factor, and you clearly see that it is a repeated factor because it is all squared. If it was all cube, it's going to be a tripled factor. Yes, so here it is repeated actually. So with that said, we have x minus 2 all squared being a factor. Yes, it's a repeated factor. So x minus 2 all squared being a factor, what does it mean? It means that my function f of x can be written as a product of its factors, which is x minus 2 all squared as one of the factors, times another factor. So the other factor, I just call it the function g of x. So x minus 2 all squared being a factor, it means that x equal to 2 is a root. So since x equal to 2 is a root, it means f of 2 is equal to 0. F of 2 being equal to 0, we just fit and we simplify in this equation. We get the first equation, which says 2a plus b is equal to 20. Now, since f of x can be written in the form as the product of its factors, which is x minus 2 all squared times the rest of the factors, then if we differentiate the function right, we are going to get f prime of x. To use the product rule, we are going to obtain this new function here as our f prime of x. And we can clearly see that if we fit x to be equal to 2, then f prime of 2 will give us 0, because the x minus 2 here, when we fit x to be 2, the factor here becomes 2 minus 2, which is 0. Here you have 0, and here you have 2 times g of 2. But anyway, since you have a 0 here already, then everything here becomes 0. So f prime of 2 is 0 as well. So this is just to remind you of the notion that if x minus 2, or if x minus a is if x minus a all squared is a factor of a polynomial f of x, then it means that x minus a as well is also a factor of the derivative, the first derivative of that polynomial. So f prime of 2 being equal to 0, we can we first of all look for f prime of x, differentiating our f of x. Differentiating x cubed, we get 3x squared. Differentiating 7x squared, we get 14x. Our negative sign stays intact. Differentiating ax, we get a, and differentiating b, we get 0, because b is a constant. So f prime of 2 being equal to 0, we just fit here. We have 3 times 2 all squared, which is 12, minus 14 times 2, which is 28. 12 minus 28 is negative 16. So negative 16 plus a will be equal to 0. So we can say a is equal to positive 16. Now from above, we have our b to be 20 minus 20 minus 2a. So 20 minus 2a, we can get the value, that's 20 minus 2 into 16, because a is 16. So our b will give us negative 12. So it means that our value of a is 16 and our value of b is negative 12. Guys, so for those of you who are following up keenly, endeavor to comment if maybe you faced a difficulty already. If you never got an explanation very well, make sure you indicate that in the comment section so we can explain using text. Alright, so let's move on to question 9. Let f be a function defined by f of x equal to 2x plus 1 divided by x plus 1. The set A for which f is surjective is. So for those of you who maybe face difficulties in functions, there is a video that I did already talking about domain of a function, the range of a function, the inverse of a function, surjectivity of a function. So I basically explained what actually this means, meaning f is to r to a, what it means, and I gave some examples. So endeavor to follow the video. I'm going to include the video link also in the description so that you can follow it to better understand functions. Alright, so a function is surjective if the codomain of the function is equivalent to the range of the function. The range of the function is the domain of the inverse. So for us to get the range, first of all we find the inverse of the function, and then later we find the domain of that inverse. We get the range of the function. What is the codomain? The codomain is a set A clearly, because a function is simply a mapping that takes elements from one set called the domain to another set called the codomain. So in this case, our domain is actually arrow minus 1, not arrow, a little mistake. So the domain here is arrow minus 1 to our codomain, which is A. So since we have been told that the function is surjective, then the domain of the inverse will just give us a codomain clearly. So the set A here is just the range of the function, which is the domain of the inverse, since the function is surjective. So first we need to get the inverse, and then we find the domain, and then we conclude. How do we get the inverse? We begin by letting the function to be y. We make x the subject of the formula. So to make x the subject of the formula, we need to cross multiply. Then we pair the terms in x together, and then later on we divide by y minus 2. We get x to be 1 minus y divided by y minus 2. So automatically we can conclude that the inverse function, f inverse, not f prime. So f inverse of x is 1 minus x divided by x minus 2. And since it's a rational function of this type, then for it to be defined, its denominator should be different from 0. So x minus 2 not equal to 0, meaning x is not equal to 2. So all real numbers excluding 2 will make the inverse of the function to be defined. So our range is the set of real numbers minus 2, and the range is clearly the codomain because the function was said to be surjective. So it means our set A just identifies the set of real numbers minus 2, that is the domain of the inverse. In other words, the range of the function. So option A is correct. Alright, so moving on to question 10, periodic functions. It reads, given that f of x is equal to 2x plus 1 for x between 0 and 2, x cubed plus 1 for x between 3 and 4, such that f of x is equal to f of x plus 3, then f of 8 is equal to. So the equation is just testing if you can recall the definition of the period of a function. So by the definition that says f of x is equal to f of x plus 3, we can see that the period of my function f is t equal to 3, and from its property it means that f of x plus 3k or f of x minus 3k will be the same as f of x for every k that is in the set, for some k that belongs to the set of natural numbers or integers. Alright, so from there we need to get f of 8. So we are going to write 8 in terms of the period. My period is 3, my k is any real number, so I need to see how I can write 8 in terms of a certain value plus or minus 3 times another value. So now we know that at the end, the value that we are putting here, that's the value that we are beginning with, should actually be in the interval of x that has been given to us. Yes, so if k is equal to 2, our period is 3, then we have 3 times 2 to be 6, then plus 2 is 8. So it means f of 8 is the same as f of 2 plus 3 times 2. Okay, so by the definition, this is the same as f of 2, because if we want to do a little comparison, right, we are just going to see that our x represents 2 here, our period is 3, and then our k is 2. So f of 8 is the same as f of 2. F of 8 being the same as f of 2, we can get f of 2 from the first function, that's the first interval from 0 to 2. 2 is included, so we can get f of 2 by just fitting 2 here. So 2 into 2 plus 1 gives us f of 2, which is our f of 8. So 2 times 2 is 4 plus 1 is 5, so it means our f of 8 is equal to 5. So option B is correct. Alright, so question 11 is on the topic probability, and the question reads, let A and B be two independent events such that the probability of the event A is half, the probability of the event B is 1 on 6. What is the probability of the event A and not the event B? So by the definition, the probability of the event A and not the event B is the probability of the event A or the event B minus the probability of the event B. Now the probability of the event A or the event B is the probability of the event A plus the probability of the event B minus the probability of the event A and the event B. Then we need to subtract the probability of the event B, which is in our formula. Alright, so probability of event B cancels with probability of event B. So we have the probability of this just gives us the probability of event A minus the probability of the event A and the event B. But since the two events are independent events, since A and B are independent events, then the probability of both of the events occurring at the same time is just the product of their probabilities occurring at their own individual times. So probability of A and B just gives us probability of A times probability of B. Now from the two terms we can factor out probability of A. We get probability of A into 1 minus probability of B. We have everything already. We have probability of A as half, we have probability of B as 1 on 6. So simplifying, we get the probability of A and not B to be 5 divided by 12. So option C is correct. Alright, so question 4 is on complex numbers, and the question reads, given I being a set of complex numbers and that Z is equal to I raised to the power I, which of the following is true? So first I'm going to demonstrate to you guys how we can get the argument and the modulus of a complex number. So let's just take our complex number. Let's just say my complex number in this case, let me just specify that it is Z1, right? So let me just say Z1 is equal to I. That's my complex number. Now how do I get the modulus? The modulus is just the square root of the square of the real part plus the square of the imaginary part. Here we just have the imaginary part and the coefficient is 1. So from there the modulus of I is just 1. Now what about the argument? To get the argument, we know that the argument of a complex number is the angle that the modulus line makes with the positive real axis. So to get the argument, first we plot the complex number to identify the quadrant, and then we use the required formula. So I'm going to plot the complex number I in our Argand diagram, and to plot it, the real part is 0 because there is no real part. The imaginary part is the part attached to I, and the coefficient is 1. So it means the real part, the point in the real part is 0, and the imaginary part, the point is 1. So from there I just need to plot the point 0, 1 on my Argand diagram. So I go to my Argand diagram, I plot 0, 1. So horizontal is for the real part and vertical is for the imaginary part. So 0, 1 just lies basically in my vertical axis. So the angle that the modulus, because this is 1, the modulus is just the distance from the origin right up to the complex number. So you see the distance from 0 to 1 is 1. So the modulus is 1, that's of I. Now the argument is the angle that the modulus line, which is this line here, the modulus line makes with the positive real axis. So the angle clearly here is 90 degrees because the complex number I is basically, that's a point represents that complex number, is basically on the vertical axis, and the angle between the vertical axis and the horizontal axis is simply 90 degrees, which is pi on 2. So that is our argument. So with that said, we can now write our complex number I in the form, in the exponential form. I'm doing that because all of my answers all of my answers are in the exponential form, right? So with that, that's why I had to get the argument of a complex number and the modulus. So my complex number I is the modulus of I times e raised to the power I times the argument of I. So with that, we have our complex number I to be e raised to the power I pi on 2 because our argument was pi on 2. The I that is here is already there in the expression. So from there we can raise both sides to the power I. Raising the right hand side to the power I therefore means we just multiply the power. So you have e raised to the power I pi on 2 times I, which is e raised to the power I squared pi on 2. But basically I squared is -1, so it means that I raised to the power I is simply e raised to the power negative pi divided by 2. So option B is correct. Alright, so we are getting closer to the end. Question 13, it reads, the parametric equations of the curve y equal to f of x are defined by x equal to cos theta plus 1 and y equal to sin theta minus 1. The equation of f of x is, So we need the equation from the parametric equations. So having x to be cos theta plus 1 and y to be sin theta minus 1, our cos theta is x minus 1 and our sin theta is y plus 1. If we square both sides and add, we get cos squared theta, which is x minus 1 all squared, plus sin squared theta, which is y plus 1 all squared. Simplifying the right hand side, we get, simplifying this first, we have x squared minus 2x plus 1. Simplifying this, we get y squared plus 2y plus 1. Now we're trying to rearrange because we want it to look like the form which is in the answers. Alright, so we have x squared plus y squared minus 2x plus 2y. 1 plus 1 is 2. Now what do we know about the identity cos squared theta plus sin squared theta? Cos squared theta plus sin squared theta is always 1, so the left hand side is 1. So 1 will be equal to x squared plus y squared minus 2x plus 2y plus 2. We can subtract 1 on both sides, so we get 2 minus 1, which will give us 1. So at the end, we see that we basically have a circle here. So this is the equation x squared plus y squared minus 2x plus 2y plus 1 equal to 0. So option C is correct. Alright, question 14. We are asked to find the image of the line y minus x equal to 0 under the transformation t, which is defined by this. And we have the various options. So basically, since this is our transformation, the first thing is that we need to get the matrix of transformation. And how do we get the matrix of transformation? We just extract the coefficients of x and y in this part of the transformation. So the coefficient of x is 1, we have 1. The coefficient of y is 1, we have 1. Down here, the coefficient of x is 1 and the coefficient of y is 0. So this is our matrix of transformation. Now we know that to find the image of any point under a transformation, we just multiply the points with the matrix of transformation. But in this case, you have a line, so we need to generalize all points on this line. We know that the line is of the form, the line is y minus x equal to 0. So it means that y is equal to x. So it means all points on that line, normally all points on the line have an x coordinate, right? And you also have a y coordinate. But in this case, the x coordinate and the y coordinate are the same because according to this, y is equal to x. So it means that all points on the line is going to be of the form x, comma, x. So to get the image of all points on this line under this transformation, we just need to multiply the matrix of transformation with the generalized points, and then we get the image. So let's just say the x coordinate of the image is x prime and the y coordinate of the image is y prime. The image of that line, you just take the matrix of transformation times your xx, like I've explained here, and you equate it to x prime y prime. Nevertheless, you're going to get a new line whose x coordinate is x prime and y coordinate is y prime. Okay, so with that said, we can multiply. We get x prime to be x plus x, which is 2x. That's matrix multiplication and equating corresponding entries since the matrices are identical. And then y prime will just be equal to 1 times x is x, 0 times x is 0, so y prime is equal to x. So from equation 1, we can get x. Our x is x prime divided by 2. We fit in equation 2 and we get y prime to be x prime divided by 2. We cross multiply with 2, we get 2y prime, then we subtract x prime minus x prime to be equal to 0. We can divide all through by the negative, so we get our answer as x prime minus 2y prime to be equal to 0. So the equation of this line y minus x equal to 0 under the transformation whose matrix we determine is just the line x minus 2y equal to 0. Alright, so next we have partial fractions. We need to dissolve this into partial fractions. So there are many rules that we use when partial fracting. First, we need to verify the degree of the polynomial in the numerator and the degree of the polynomial in the denominator. If they have the same degree, we undergo long division first. If the degree in the numerator is greater than the degree in the denominator, we still undergo long division. But if the degree in the numerator is less than the degree in the denominator, we ride on with a partial fraction. So Here we see that the degree in the numerator is 3, the degree in the denominator is 3. So we need to undergo long division. But nevertheless, I'm going to show you a trick which will permit you not to undergo long division, but anyways, you're still doing long division but in a different way. So what we do is that we make the denominator, since the numerator has x cubed and the denominator has x cubed, then we need to make the numerator to resemble the denominator. So the denominator is x cubed minus 1. So in the x cubed, which is the numerator, I need to subtract a 1. But for me to arrive back at x cubed, I need to still add the 1 because negative 1 plus 1 is 0. Looking at this, I have not changed anything. Now I'm going to pair x cubed minus 1 as one quantity, and I'm going to allow 1 as another quantity. So I'm going to get x cubed minus 1, then divided by x cubed minus 1, then plus 1, then divided by x cubed minus 1. Alright, with that, this you are going to get, dividing this you get 1, and then dividing this you just get 1 over x cubed minus 1. Now we need to verify if the denominator can be reduced. Yes, it can be reduced. X cubed minus 1 can be written as x minus 1 times x squared plus x plus 1. So it means that 1 plus this quantity is just 1 plus 1 over x minus 1 times x squared plus x plus 1. So from here, I'm good to go. Everything has already been reduced and in the form where I can introduce now my constants. So in the numerator of the numerator of x minus 1, you're going to put a constant because it is linear, and the numerator of x squared plus x plus 1, you're going to put something linear because it is quadratic. So it means this will be equivalent to p over x minus 1 plus qx plus r over x squared plus x plus 1. So looking at things, we see that option A is correct. Sorry, it is supposed to be for some p, q and r in the set of real numbers, not for all. So sorry for the mistake. So it's supposed to be for some. Alright, so option A is correct. Question 16. Given that the roots of the equation x squared plus 6x plus c equals 0 differ by 2 alpha, with alpha and c being in the set of natural numbers, the possible value of alpha plus 2c is, I think this was one of the most trickish questions, and up to now we have received around 30 students who have taken part in the evaluation and nobody has passed this question. Yes, it is an MCQ, but nevertheless we know that the probability of you passing the question is 25%, so it is actually possible, but nobody has passed the question. Anyways, follow keenly because the solution is very, very technical. So let's go. Since they said the roots of the equation differ by 2 alpha, then my roots are going to be, one is beta, the other is going to be beta minus 2 alpha. So with that said, we begin with the sum of roots of the equation. The sum of roots is adding beta to beta minus 2 alpha. So we have beta plus beta minus 2 alpha. But the sum of roots, since the quadratic is negative b on a, negative b is negative 6 and a is 1. So we have negative 6. Now if you add beta to beta, we get 2 beta. So we have 2 beta minus 2 alpha to be negative 6. We can now divide all through by 2. We get beta minus alpha to be negative 3. Remember that when we divide by 2, we are making things get better. Alright, so we now do the product of roots as well. Doing the product of roots, meaning we multiply beta with beta minus 2 alpha, we get c on a. Our c is just c, that's a constant term, divided by a is 1. Now from our equation here, we can get the value of beta. Beta is just negative 3 plus alpha by adding alpha on both sides. So you have beta into negative 3 plus alpha, then minus 2 alpha, which is originally there, to be equal to c. Now alpha minus 2 alpha is minus alpha. We also know the value of beta as negative 3 plus alpha, so we fit as well. So we have negative 3 plus alpha times negative 3 minus alpha to be c. We can divide all through by the negative sign, and we just attach the negative sign to c here. This quantity here becomes 3 plus alpha, and this becomes alpha minus 3. That's basically a difference of 2 squares, which is alpha squared minus 9. Nevertheless, even if you multiply, you're going to get you're going to get the same response. So alpha squared minus 1 will be equal to negative c. We can add 9 on both sides, and we get an equation which relates alpha and c. Alpha squared is equal to 9 minus c. Now getting back to our equation, we're being told that alpha and c are natural numbers. So alpha squared will definitely also be a natural number, and 9 minus c will also be a natural number, because c being a natural number and you're taking a natural number minus another natural number, you also get a natural number. So what I'm going to do is that I'm going to write alpha squared as alpha times alpha, and I'm going to write 9 minus c as 1 times 9 minus c. That's just a possibility. So equating maybe like entries, right? We take alpha to be equal to 1, and then now alpha as well to be equal to 9 minus c. So alpha being equal to 1 and alpha being equal to 9 minus c, if I multiply alpha and alpha, I'm going to get alpha squared. If I multiply 1 and 9 minus c, I'm going to get 9 minus c. So alpha being equal to 1 is already, we already get the value of alpha as 1. What about c? Our c is just 9 minus alpha, which is 9 minus 1, which is 8. So for alpha equal to 1, our c is equal to 8. Let's come back to our equation to verify if it is true. If alpha is 1, the left hand side is 1 squared, and c is 8, the right hand side is 9 minus 8, which is still 1. So it is okay, and both 1 and 8 are in the set of natural numbers. So it means that the possible values of alpha, though I have another value, another possible value of the couple alpha c. So alpha is 1, c is 8, or even alpha being 2 and c being 5 can also work. Now if alpha is 1 and c is 2, what is alpha plus 2c? Is 1 plus 2 into 8, which gives us 17. So option B already is okay. But nevertheless, if alpha is 2 and c is 5, alpha plus 2c will give you 2 plus 2 into 5, which will give you 12. That's why I never included the response here. So 17 is okay. So option B is correct. Alright, so we are getting close to the end. Here is question 17. It reads, we need to find the statement P and Q, the equivalence that's in worded form, where the statement P is trust in the Lord always, and the statement Q is lean not on your own understanding. Alright, so we need to get P and Q. So P and Q, we are just trying to link the two statements with a conjunction and. So we need to get an and that is linking the two statements. So P says trust in the Lord always, and then when we see the and, it means it was linking the two statements. And Q says lean not on your own understanding. So option A is one answer. What about option B? We know that P and Q is also equivalent to Q and P. Yes, so option B is also a correct answer. Lean not on your own understanding and trust in the Lord always. So in this question we had two correct responses, and the students were supposed to pick the two responses. Right, so option A is correct and option B is correct. Question 18, the arc length L is, now the arc length is a distance from A to B on this arc. Now how do we get it? The arc length is simply the radius of the circle times the angle subtended at the center, which is theta. Since the radius is 1, that's the distance from the center to any point on the circumference is indicated as 1, then our arc length will just be equal to the angle subtended at the center, and this angle is always supposed to be in radians. So we need to get that angle. So first I'm going to depict this triangle here. We are going to cut the triangle into two right angle triangles, and since that line there is basically a perpendicular bisector of that angle and of the segment AB, that's the chord AB. Alright, so it divides the angle theta into two equal parts, alpha and alpha. So clearly theta is equal to alpha plus alpha, that's theta is equal to 2 alpha. So we are going to get alpha and then later we get theta. Now the radius of my circle is 1, so it's the hypotenuse of this right angle triangle to the left as well as the hypotenuse of the right angle triangle to the right. Now since this is a perpendicular bisector of that angle, it means it bisects the chord AB into 2. So the length of AB is root 3, means that this portion here is root 3 on 2 and this other portion is root 3 on 2. Now we can use SOHCAHTOA. We use sine alpha to be the opposite, which is root 3 on 2, divided by the hypotenuse, which is 1. We now get our alpha to be 60 degrees, that is pi divided by 3. What about theta? Theta is 2 alpha, so it means our theta is 2 pi divided by 3. But our theta is the same as the arc length, so our arc length is 2 pi divided by 3 units. So option A is correct. The last but not least question 19, also a very tricky question. This was the only structural question. In the beginning, I told you guys that the exam was divided into 20 questions, 19 multiple choice and one structural. So this is a structural that we are talking about. The students were not required to solve and present their solutions, but they were just required to write their answer in this case that was provided. Alright, so to recall, if n combination p is equal to n combination r, then n minus p is equal to r, or n minus r is equal to p, the same thing. So if I look at this, this is just a shortcut, though we can perform the combinations and all the rest, but it's going to be longer. So I'm trying to give you what you can use to fasten up your time. Alright, so remember we are facing the GCE here, and the essence of the examination is for you to think, for you to explore your thinking abilities and be able to tackle questions with a greater speed. Alright, so 12 combination 4 equal to 12 combination r, it means that 12 minus 4 is equal to r, or 12 minus r is equal to 4, and you get r. So nevertheless, our r will give us 8, so that was a response. And question number 20, one of the second most interesting problem, aside the problem that we're asked to get the possible value of alpha plus 2c. So this problem is very interesting because visualizing graphs and then using relationships to get what you want is something that is not really common among our students. So the equation reads, given that g of x is equal to f of x divided by 5x, then g prime of 3 is equal to, alright, so first I am going to get g prime of x before I get g prime of 3. Now since it's g of x, my graph, I have the graph of f of x, and then I can use the quotient rule here to get the derivative, that's to get g prime of x. So g prime of x is equal to 1 on 5. I put the constant out, and I'll use the quotient rule. I keep the denominator, which is x. I differentiate the numerator, f prime of x, minus, I keep the numerator, which is f of x. I differentiate the denominator. Remember, we are differentiating with respect to x. Differentiate the denominator with respect to x to get 1, then divided by the square of the denominator. Now from there, what's g prime of 3 is 1 fit into, replace x with 3 times f prime of 3 minus f of 3 divided by 3 squared. Now the problem is to get f prime of 3, because clearly from our graph we can get f of 3. When x is equal to 3, our f is equal to 5, so it means f of 3 is equal to 5. Now we need to get f prime of 3. How do we now get f prime of 3? First, we are going to use the concept of the turning points, and secondly, that's method 1 is the concept of the turning points, and method 2 we apply the mean value theorem in a specified interval here. Alright, so taking the concept of the turning points, you know that at the turning point the derivative of the function is always equal to 0. So we clearly see that here the function turns here, so f prime of 3 will clearly give you 0, because f prime of x at this turning point here is 0, and this is the maximum turning point nevertheless. So it means our f prime of 3 is equal to 0. How can we also visualize it using the mean value theorem? The mean value theorem says that if a function is continuous in a certain interval and also derivable in that interval, let's just say the interval is a to b, then what happens is that if I pick any point if I pick c, which is between a and b, then the derivative of my function at the point c is just equal to f of b minus f of a divided by b minus a. So I come and I see that my function clearly is continuous in the interval 1 less than or equal to x less than or equal to 5, and I can pick 3 as my c because c is between the two intervals. So it means that my f prime of 3 will give me f of 5, that is f of the maximum of the value of x in my interval, minus f of a. F of a is f of 1, then divided by b minus a, 5 minus 1. But f of 5 is clearly 0 because my function gets the x-axis when x is equal to 5. Same scenario for f of 1. F of 1 is 0 because the function gets the x-axis when x is equal to 1. So with that, we get our f prime of 3 to be equal to 0. So using the mean value theorem or using our concept of turning points, we are good to go. So f prime of 3 is equal to 0. So it means our g prime of 3 is equal to 3 times 0 minus 5, all divided by 3 squared. So simplifying, we get our g prime of 3 to be negative 1 divided by 9. So guys, we have come to the end of the video, and make sure you like the video, subscribe to the channel, turn on your notifications so that whenever videos are uploaded you always be notified. For those of you who took the exam, don't be discouraged with your mark because so many people fail the exam. Yes, like I said, as it stands we have 30 responses and about 3 people have passed the exam, one with 18, one with 17, and the other with, I think, maybe 11 or 13, I can't remember well. But the marks are not to discourage you, they are just to tell you that you are preparing for the GCE, so you need to be extremely fast in solving, you need to be wise in solving. So next week we are also going to launch for physics, and we are going to update you guys. So for those of you who have not yet taken the test, please check the description of this video. I have included the link which will permit you to take the test. It's a 30 minutes exam, so you'll be able to see your score after you submit your responses. You're able to see the correct answers, but you'll not be able to see the solvings. That's why we decided to do a solving game. Alright, so guys, see you in the next video, and thanks for watching.